Let's discuss a question from strength of materials. Okay, so you have a rod spinning about its end in the spinning axis vertical, so the rod spins in the horizontal plane. And so what is asked is the ratio of the stress in the rod at x equal to L by 2 to is n times the ratio of the stress at x equal to 0. So value of n is asked. So basically we need to actually find out what is the expression of the stress in this rod as it spins through about the vertical axis. Now this can be easily said. So all these are kind of a simple stress and strain problems where what you have to always do is take a section and take either the left side or the right side of the object, balance it, and then see what is the stress. So what we do is the same thing. We take a section at x and take the right side body. Now the right side body is basically like this. Okay, so what are the forces on it? Now the left side body, because we are taking the right side body, the left side body will exert some force. So let's say that is tension T, okay, or the actual force which is T. Now this there is no other force. The gravitational force is there, which is in this way, the mass of this into G, okay. And now, but remember that this body spins in a circular motion. So any particle which is moving in a circular motion has tangential acceleration, okay. So it has tangential is again, so tangent to this circle, okay, as well as a normal acceleration. So we are interested in the normal acceleration because that normal acceleration will be supported, actually the reason or the cause of that normal acceleration will be the normal force on this, and the normal force is nothing but this tension T, and that will ultimately leads to the stress. So this is assuming that the CG of this particle, the CG will be at the center. So at this CG, let's say that CG is at a distance r from the spinning axis, okay. So once this is x, so r would be, so this is L minus x, and this is the CG. So this is r, CG of the right side portion. So r is nothing but x plus, it will be a half of L minus x by 2. So that is nothing but L plus x by 2. That is the CG from the spinning axis. Now at this CG, what are the forces? You have a tangential acceleration which is MAT, which is nothing but mr alpha, and alpha is 0 because it moves with constant angular velocity, whereas the normal force is mr omega square, okay, which is nothing but your centripetal force. So mr omega square, m is the mass of this right side section. So this, now if you balance this, so these are the inertia diagram. This, the right side is the forces at the inertial forces at the CG, whereas if you take only the normal and the tangential force, okay, so this is the normal force acting in there. So if you balance the tension, balance the forces, and I mean the summation of all the forces should provide this inertial normal force. So that is tension here, left side we take positive, so this tension should provide you the normal acceleration, the inertia force due to normal acceleration, which is nothing but mr omega square. So now what is r we know in terms of x, but this m is for the right side portion. Now total, remember the density is uniform, so the total mass is for the length L, whereas for the length L minus x we have the mass m. So obviously it will be linearly distributed, okay, because again the area of cross section is uniform, the density is uniform, so density into area into length makes the total mass, so it's proportional to length. So m by capital M will be L minus x by L. So m, which is the mass of the right side section, will be m L minus x by L. What I am doing is I am trying to drive an expression for the stress. So m L minus x by L is the mass, okay, and x we know it is L plus x by 2, and that is omega square. So this is the so this is the tension or the force exerted by the left side of the section, left side of the body on the right side, and that is tension T. So this value we get m L square minus h square by 2 L omega naught square. Okay, we can put omega naught because omega naught is what is given. And so what is the stress? The stress is tension. This is the force which provides you the normal inertial force. Tension by area, which is nothing but m L. So m is capital now because the total mass is taken care. Most of the people, what they do mistakes here is that they will consider this m as the total mass, but this has to be the right side section, and that is not the total m. That is again we need to find out by this. Okay, so now this is the stress at any distribution. So we derived a general expression for the stress. Now let's see what is asked. N is defined as the stress at x equal to L by 2 by stress at x equal to 0. Substitute L by 2, so everything else is constant, so I think only the numerator will change. L minus L by 2 whole square, okay, by everything constant, into divided by x equal to 0, which is again L square. So now everything else will get cancelled, so it is L square by 4, so 3 by 4, yeah, 3 by 4 is the ratio. Okay, so that is 0.75 is the answer. So 0.75 is the answer for this. Okay, ratio of stress in the rod at L by 2 to, because it depends on L minus x whole square, so that is important. Okay, so this anything can be asked on this. So we have just derived a general expression. Remember that how we have derived it, general expression for stress, and then the ratio is asked. Thank you.